Today, we're going to talk about a really fundamental shift in how we build our world. It's called sustainable engineering. And really, it's about moving beyond just building bigger and faster. Instead, it's about designing a future that's smarter, more resilient, and that actually works in harmony with our planet.
For generations, the goals of engineering were pretty straightforward. Success was measured by a simple formula. Could you build it faster, stronger, and cheaper? That was the name of the game. But today, the rules have completely changed. Now we're thinking about things like sustainability, our environmental impact, and even our social responsibility. The whole picture is just so much more complex, and frankly, a lot more important. So what do we actually mean by sustainable engineering? Well, at its core, it's all about finding a crucial balance. It's the practice of designing and building systems that meet our needs today, but without messing things up for future generations. So it's not just about what we build, but how we build it. You could almost call it engineering with a conscience.
So why is this shift happening right now? Why is it so urgent? To get that, we need to look at the very backbone of our society, our infrastructure. For decades, we designed these systems, our roads, our power grids, our water pipes, to be static, unchanging. We built them to last, sure, but we didn't really build them to adapt. And that's the heart of the problem we're facing today.
These old, static systems, they're cracking under the immense pressure of the 21st century. We have rapid urbanization packing more and more people into cities, our global population just keeps growing, and of course, climate change is bringing more frequent and extreme weather. It's kind of the perfect storm of pressures, and our legacy infrastructure just wasn't designed to handle it.
So, what's the solution? Well, this brings us to the rise of smart systems. We're at this incredible moment, this technological tipping point, where we can actually integrate digital intelligence directly into our physical world. For the first time, our infrastructure can become responsive, adaptive.
So, smart infrastructure. Think of it like we're embedding a nervous system into our cities. We're talking about sensors, networks, and data analysis that allow our physical systems to monitor themselves, collect data, and then adjust to changing conditions in real time. It's really the difference between a rigid skeleton and a living, breathing organism.
Now, I know this might still sound a bit abstract, so let's make it concrete. We're going to look at how this digital intelligence is already transforming three critical areas of our daily lives: how we move around, how we power our homes, and how we manage our most precious resource, water.
Let's start with something we can all relate to: traffic. Gridlock doesn't just waste our time and fuel, right? It pollutes our air, and it's incredibly stressful. But what if our streets could actually think? Well, smart technology is offering a pretty powerful way to start untangling this daily knot.
So, here's how it works. First, a whole network of sensors and cameras collects real-time data on how traffic is flowing. Then, an intelligent system analyzes all that data to identify patterns and maybe even predict congestion before it gets bad. And then, this is the cool part, it dynamically adjusts the timing of traffic lights to optimize the flow of cars. And the result? We spend less time idling at red lights, which directly cuts down on fuel use and harmful emissions. Pretty clever.
Okay, now let's turn to energy. For over a century, our power grid has operated on a really simple but fundamentally limited one-way model. That's all starting to change as we build a smarter, more dynamic, two-way power grid.
The traditional grid is a one-way street. You have these massive power plants that generate electricity and just push it out to us, the consumers. A smart grid, though, enables a two-way conversation. So this means that homes with solar panels aren't just consumers anymore, they can be producers too. They can use the energy they need and then sell any extra power back to the grid. They effectively become these miniature power stations, making the whole network more resilient.
And this same kind of intelligence extends to water management and even the buildings we're in right now. Imagine smart sensors in city pipes that can detect hidden leaks before they waste millions of gallons of water. Or think about smart irrigation on farms that checks the soil moisture and gives crops the exact amount of water they need. No more, no less. And inside our buildings, automated systems can dim the lights or adjust the AC in empty rooms. It's all about efficiency at every single level.
But bringing this smart, sustainable future to life, well, it isn't just about cool new technology. It requires a pretty fundamental shift in our thinking. And we have to have a clear-eyed view of the challenges ahead. So let's talk about the long-term strategy and some of the real-world hurdles we need to overcome.
A core part of this new strategy is something called the life cycle approach. See, traditionally, engineers focused mostly on the upfront cost of construction.
But now, sustainable engineers consider the entire lifespan of a project. They look at the impact at every single stage, from getting the raw materials to manufacturing, construction, operation, all the way to its eventual disposal or recycling. It's a holistic view, where maybe a more expensive material upfront actually saves a fortune in energy and maintenance costs over decades.
This vision is really compelling, but it's not simple. It's far from it. So, what are the real-world hurdles that are blocking the path to this smart, sustainable future?
It really comes down to three big ones. First, there's the cost. This advanced technology requires a huge upfront investment. Second is data and privacy. A smart city is a data-rich city, and we have a profound responsibility to make sure that data is secure and used ethically. And finally, and this might be the most important, is public trust. This whole technological shift will only work if people understand it, accept it, and are willing to adapt their own behavior.
So as we start to wrap up, it's worth just refocusing on the ultimate goal here. With all these challenges, why is this transition so critical? It's because we're laying the groundwork for a fundamentally different, more intelligent, and more livable future.
This guiding principle really says it all. The ultimate goal is to create infrastructure that isn't just strong, but is efficient in how it uses resources, that's resilient enough to handle shocks like extreme weather, and adaptable enough to evolve and meet the challenges of a future we can't even predict yet.
Ultimately, this conversation isn't just for engineers. Understanding these principles empowers all of us, as citizens, as consumers, as leaders in our communities, to ask the right questions and make informed decisions. It's really a shared project, building a more sustainable and intelligent world for everyone.
So please keep in mind that the ideas we've discussed today aren't just theoretical. They are the blueprints for the cities and the systems of tomorrow. So it's important that you understand them. This material is foundational, and you can expect to see it on your midterm and final exams. Thank you.